In this lecture, we are going to see the control unit design of a single cycle processor. Till the last lecture, we are dealing with the data path design of a single cycle processor. So here we are going to deal the control unit design for the same processor. So the control unit, what is the function of a control unit? Control unit computes the control signals based on the control field, condition field, opcode field and function field of the instruction. So which is a condition field? Bit number 28 to 31. So what is this thing? This is a binary encoded format of a data processing instruction. For example, I have taken data processing instruction. All the instruction will be having similar binary encoded format. So bit number 28 to 31 is a condition field. Bit number 26 to 27 is the opcode field. And bit number 20 to 25 is the function field. Based on all these fields, control units compute the control signals. And in addition to that, it also sets the flags. Then it can also modify the PC if the destination register is given as R15 or PC. Right. So the control unit also stores the current status flags and updates them appropriately. Whatever based on the arithmetic or logical instruction, your status flags will be changing. So if those changes are to be done, that also will be done by the control unit. So this is a complete block diagram of a single cycle control unit, single cycle processor control unit. You can, all these blocks we have already seen. Whatever it is shown in the blue color is a control unit with the corresponding control signals, right? So in the control unit, it is basically divided into two parts. First one is known as a decoder. This is a decoder. Second one is known as a condition logic, right? So what does a decoder do? Decoder will generate control signals based on the instruction. Based on the instruction, it will generate the control signal. What does a condition logic do? It maintains the status flag and only updates the architectural state whenever it is to be executed. So based on the conditional instruction what you have seen here, based on the conditional instruction, the control unit, the conditional logic will change the architectural state of your processor. Change the architectural state means it will change the processor from one state to another state by using this control signals such as PC source, register write, memory write, etc. Right? So based on the signal and the signals will be generated based on the condition, right? As a result of this, the architectural state of the processor will change. So basic function of control unit is to keep track of the condition, right? So if you are writing an instruction, say add EQ, one operation like that, so that means the addition will be taking place only when zero flag is set. EQ stands for equal to. So when the zero flag is set, your addition will take place. So those conditional execution will be handled by the conditional logic, right? Then, so we have seen there are two parts, the decoder and the conditional logic, and the decoder itself is divided into three parts. They are known as main decoder, ALU decoder, and the PC logic. Right? You can see here. So this is a decoder. It is divided into three parts. One is the main decoder, which generates most of the control signals. Another one is the ALU decoder, which instructs the ALU to do something. Then the final one is a PC logic, which will be updating the PC based on some condition. So main decoder, it produces or generates most of the control signals. ALU decoder uses the function field, which is a function field bit number 20 to 25 of the binary decoded format. Uses the function field to determine the type of data processing instruction. Based on these fields, the data processing instruction will be executed by the ALU decoder. PC logic, it will determine whether the PC needs to be updated by using a branch or due to a branch instruction or a direct write into the R15, because R15 is nothing but PC. So if you are use, if you are writing some data into R15 directly by setting the destination register as R15, what will happen? The PC will change. So PC logic will determine whether the PC needs to be updated based on the branch or based on the writes directly to R15. Right? So decoder consists of these three parts. Then then each block we will see one by one. First we will see the main decoder. So the main decoder determines the type of instruction. We have already told. So it determines the type of instruction, whether it is data processing instruction using register addressing, or data processing instruction with immediate addressing, or store instruction, or load instruction, or branch instruction. So this main decoder is detecting whether the type of instructions are any one of this, and based on that control signal will be generated. Then it also sends memory to register ALU source, immediate source 01, and register source 01 directly to a data path. These are those bits: memory to register, ALU source, immediate source, and register source. These things we have already seen here. So ALU source, it is used for selecting the second operand, whether it should be read from the register file or from the immediate sign extended immediate value. This is used for, it is done by using ALU source. Immediate source is for selecting the type of sign extension you need, whether it is 8-bit sign extension, 12-bit sign extension, or 24-bit sign extension. Then the memory to reg signal is used for selecting the output of data memory to be written to here, or whether the ALU result need to be written to this, or this is also used for writing the data to the PC, right? So memory to register is used for selecting the input in this multiplexer. ALU source is used for selecting input from using this multiplexer. Immediate source is used for selecting the immediate value, and the ALU control is used for selecting the operation that has to be done on the ALU, whether it is add, and, or subtract, right? So these are the control signals which are generated by the main decoder, right? Then it also enables the write enable, such as memory write and register write, these things, and it will be passed through the control logic, becoming data path signals memory write and register write. You can see the register write and memory write is connected to the conditional logic, and if the condition is satisfied based on the conditional field in the instruction, this will be connected to the register write and register or memory register write or memory write. So if the condition is true, the second input of these two AND gates will be set, so that whatever you are giving in the first input will be coming at the output. So if the condition is true, then these two signals, reg write and memory write signal, will be connected to register write and memory write. So what is the function of register write and memory write? Register write is used for writing, it is used as a write enable for register. Memory write is used as a write enable for the data memory. If you want to write something into data memory, you need to make this memory write as 1. If you want to write something in the register file, you need to make register write as 1, right? So all these signals are generated by the main decoder. Then these write enables will be killed if the condition logic is false. If the condition is false, that is what is shown here. Because if the condition function is giving the output false, these two inputs will be 0. So the AND gate output will be 0. So what these two signals are controlled by the condition logic. Then it also generates the branch and ALU outputs based on the branch or data processing instruction. You can see here the main decoder generates branch or ALU output. So if you are trying to execute some branch instruction, this signal will be given to the PC logic. So PC will be updated appropriately. How to update the PC we have already seen while executing the branch instruction in one of my previous lecture. Then this main logic or main decoder also will generate another signal known as ALU output. This ALU output will tell the ALU decoder to perform some data processing instruction. So these two signals are also generated by the main decoder, that is a branch signal as well as ALU output. So ALU output tells the or instructs the ALU decoder to perform some data processing instruction. That is a function of main decoder. So this is a truth table showing the main decoder operation. So here you can see you are having opcode field 2 bits, then function field, fifth bit of function field, that is this, then 0th bit of function field, that is this, right? So 0th bit of function field is S. So if S is set, whatever operation, whatever arithmetic or logical operation you are performing, the flags will be set. If S is 0, flags will not be set. Then so if the opcode field is 00, what does it mean? If opcode field is 00, the processor will identify that you are going to perform some data processing instruction with register addressing. Data processing instruction with register addressing. So the following signals will be set. Branch will be 0, memory to register will be 0, memory write will be 0 because you are using data processing. Then ALU source will be 0, like that. Similarly, if the opcode field is 00 and the function field is 1, previously function field fifth bit was 1, so this fifth bit is used for selecting whether you are performing data processing with immediate addressing or register addressing. If the fifth bit of function field is 0, that means you are performing register addressing. If the fifth bit is 1, that means you are performing immediate addressing. So if the opcode field is 00 and function field fifth bit, immediate bit is 1, then you will be performing data processing with immediate addressing, right? Then if it is 0 1 in the opcode field, here it can be any value, so it performs store operation. If it is 0 1 and the function field is all, function field 0 is 1, function field means this. So for the store and load, it is having another operation. For the store and load, if this bit is 0, it means store. If this bit is 1, it means load. And the corresponding opcode bit should be 0 1. So 0 0 stands for data processing instruction, 0 1 stands for load or store, and even though the 0 1 is there, you need to set the function 0th bit as 0 for store and function 0th bit as 1 for load. So 0 1 represents whether it is store or load, and 1 0 represents for branching, right? So that is how, based on the opcode field, you are selecting data processing instruction. The processor will be selecting control signals for data processing instruction or store or load instruction or branch instruction, right? Then we have told the ALU output signal which is coming from here. So if the ALU output signal is 0, that means no data processing instruction has to be done, right? If this bit is 0, it will tell the ALU decoder that you don't need to perform any data processing. If ALU output is 1, then it needs to perform the data processing instruction. How it will perform the, how it will or identify which data processing instruction it should do, based on the command, these 4 bits command field. So if these 4 bits are 0 and 0 0, you are performing AND. If these 4 bits are 0 0 1 0, you will be performing sub. If these 4 bits are 0 0 0 0, you will perform AND. Here it is add, here it is AND. Then 1 1 0 0, you will be performing OR, right? So based on this value, corresponding data processing operation will be done. And there is one more field known as the S field. So I told, if S bit is 0, the flags will be updated. Which are the, how you will update the flag? Based on this control signal known as flag W. So this flag W signal, how it is reflecting the flag, we will see later. So based on these 2 bits, the if the S bit is 0, flag bit will not be reflected, that is why it is 0 0. If this bit is 1, flag bits 0 and 1 1, 0 and 1 will be 1 1, that means two flags will be reflected, right? Similarly, if it is sub and S is 1, flags will be reflected. If S is 0, flags will not be reflected. Similarly, if it is and S bit is 1, you need to see that flag bit 1 will be 1, flag bit 0 will be 0. That means in and the sub, all the four flags will be updated based on the condition, based on the operation. But in and or, only two flags bit will be set. You are having four flags: N, Z, C, V, Q. Negative flag, zero flag, carry flag, overflow flag. So in the case of add and sub, only two flag bits will be set. All four flag bits will be set. That is N, Z, C, V, Q. But in and or, only two flags will be set, right? So each bit is used for enabling two flags. So here first bit is 1, that means two flags will be set. Other bit was 0, so the next two flags will be cleared or it will not be reflected. So if S bit is 1, then only the flags will be reflected. You can see in each instruction. If S bit is 0, flag bit will not be reflected. So flag bit is having two bits. Why? Because one bit is used for reflecting two bits of the actual two flag bits, that is NZCVQ. Out of that, first bit is used for representing two bits, two flags. Another bit is used for representing another two flags. So add and sub, all the four flags will be updated. In and or, only two flags will be updated. The other two flags will not be updated. So this is a truth table representing the main decoder functionality. Then we will see the ALU decoder. So all these three are main decoder, ALU decoder and PC logic is a part of the decoder. So we have seen the main decoder. Now we are seeing the ALU decoder. So what does the ALU decoder do? It is used for data processing instructions, right? So ALU decoder chooses the ALU control signal based on the type of instruction: add, sub, and source, and or, right? You can see one ALU control signal is there, this signal. So this signal is generated by ALU decoder. So this signal decides which operation should be done on a processor, whether it is AND, add, sub or. Then it also asserts the flag W to update the flag bits. If S bit is set, you can see it will assert the flag bit, it will assert the flag W signal for updating the status flag when the S bit is set. Otherwise it will not be reflected or updated. So the ALU decoder generate two signal. One is the ALU control. It is used for deciding which operation should be done on the ALU, whether it is add, sub, and or. And flag W control bit decides which flag bit should be updated, right? Whether it is C flag, the V flag or N flag or Z flag, and this will be updated only when the S bit is set, right? And you need to keep this in mind. So and for and sub operation, it will update all the flags. Just now I have told, for and sub, all the four flags will be updated based on the operation. But for add and sub, all flags will be updated. For and or, that is a logical operation. For the arithmetic operation, all the flags will be updated. For the logical operation such as and or, only N and Z flag, only two flags will be reflected. Here four flags will be reflected. So in order to generate signals for two sets of flag, you need to have two bits for flag W. That is why two bits are given for or dedicated for the flag W field, right? So the flag W1 is used for, that is flag bit, first flag control signal, first bit is used for updating N and Z. Zeroth bit is used for updating C and V. So here you can see the flag W bits are having two bits. If flag W and the zeroth bit of flag W bit is used as enable for updating C and V, carry flag and overflow flag, and the first bit of flag W is used as an enable for updating N and Z. It is not directly updating the flag, it is used as an enable signal. And based on the operation, right, say if you are performing AND operation, this signal will be set by the ALU. You can see this is the ALU. So if you are performing to say AND operation, add operation, right, say FF plus FF, you are performing FF plus FF. So when you are performing FF plus FF, you will be having a carry flag will be set. So based on the operation here, ALU flags will be set by the ALU, right? ALU flags will be set by the ALU. So this flag bit, it is having 4 bits, that is connected here. 4 bits will be set by the ALU. Why 4 bits? 4 flags are there. N, Z, C, V. 4 flags are there. So based on this ALU operation, whatever you have done, any of those 4 flags will be set. This signal is connected to the condition check field. So based on this flag, either say N and C will be set, but if those has to be set, the corresponding enable has to be generated by the ALU decoder. So ALU decoder is generating the enables for setting NZ and CB, right? So if you are executing add or sub instruction, both these enables will be set. Why? Because all the 4 flags may be reflected based on the condition. So for add and sub, both these enables will be set. Both these bits will be set. That is why you can see here 1 1, right? Both the bits will be set to 1 1, right? So 0 bit will be 1 and first bit will be 1. That means both these enables will be 1. So if the instructions add or sub, any of these 4 flags can be updated, right? But if it is AND or, if it is an arithmetic operation AND or, you can see that only the 0th bit, only the first bit will be set. First bit of flag W, right? So for and or, only the first bit of flag W will be set. So first bit of flag W means it only the enable for N and Z will be set, right? So if you are performing logical operations such as AND or, the first bit of flag W will only be set. 0th bit will be cleared. Only the first bit will be set. That means the enable will be given only for N and Z flag. The enable will not be given for C and V, right? So enable will be given only for N and Z, and based on the instruction either N or Z can be set based on the flags which is generated by this, right? And whatever you are writing here will not be reflected here. Why? Because this enable is 0. So you need to keep in mind, if you are using AND and sub, add and sub, all the flags will be reflected. So both the bits will be set. Flag bit 0 and 1 will be set. For logical operation and or, only the first bit will be set, other bit will not be set. So it will be updating only the 2 bits, right? And the flag bits will be killed if the conditional logic is providing an output 0. So all those signals will be generated, are controlled by using the condition check field or the conditional logic. So if the conditional logic is giving a 0 signal, all the flag enables will be 0, right? So I told all the instructions are having a condition field. If the condition field is not satisfied, then it will be generating a 0. So whatever you are generating here will not be reflected here, because output of AND gate will be 0 when this is 0. So the control the flag bit will be killed if the conditional logic condition is not satisfied. So this is with the ALU decoder. Then the third part is the PC logic. So all these are parts of the decoder circuit. Third one is PC logic. The PC logic will check if the instruction is a write to R15 register or a branching instruction. So PC logic decides what has to be done with the PC. Whether the PC should be updated by using PC or branching, whether the PC need to be updated by using branch or the PC need to be updated by directly writing into R15, right? So if you are using a branch instruction, your memory to register value will be 0. So the result of the ALU operation, result of the ALU will be returned to the PC. We have seen this while you are dealing with the branch instruction. We can go through that lecture. So if the memory to register bit is 0, the result of the branch which is coming from the ALU will be connected to the PC, and if PC source is 1, that will be connected to the PC, right? Or the PC should be updated based on the based on writing to R15. So here you can see this is a PC logic. PC logic decides what needs to be done with the PC source, right? Or what should be connected, what need to be done with the PC source, whether it is based on writing value directly into the destination register known as R15, right? So these four bits are RD0 to 4 is used for representing the destination register. You have already seen. So if the destination register is R15 and if you are writing a value into R15, so PC will be updated based on this, or PC need to be updated based on the branch instruction, right? So the actual logic is PCS, that is the PC source will be equal to RD equal to 15 and WReg. So the reg W means you are generating a register write signal, right? If you are writing by use is a you are setting the destination as R15, then you are giving a data into the register file, but it will be updated only when register write is set. You can see here, this is a circuit diagram. So say R15 you are giving as a destination, this is a destination. So you are setting R15 as destination. So the R15 will be the address of the R15 will be given to A2, right? So A2 will be selecting the destination as R15, and whatever value you are writing, that value that value should be written to this, right? So this is a destination R15, not this, there is a mistake. So this is R15, so R15 will be selected based on this, and whatever value you are writing, it will be written to R15. So how will you write? You need to select this signal, so R15 will be selected and a register write should be given, right? So the PC can be updated in the branch operation. How it is done? You will be selecting, and not in the branch operation. How will you write directly into R15? R15 should be selected as the destination. So R15 is selected destination by using this, and you are writing to the register file, right? So that is how it is done. So you are making R15 as the destination register, and you are giving the register write. Okay, this is a register write. Whenever you have register write, then only it will be written to R15. So if this operation is performed, then PC will be updated based on this value, or it can be performed using a branch operation, branch. So this PC logic decides whether the PC need to be updated based on the writing into the R15 register or based on the branch instruction. So for the branch instruction, I told the destination will be calculated based on the by using the, this is a branch instruction. So the ALU will be calculating the result of the branch by using 24-bit addressing, and this result you are writing to the PC. You can see here. So PC source should be 1 if branch instruction has to be the address has to be supplied from the branch, right? So this will be connected to the PC, right? In the case of branch. So in the case of branch, the address will be supplied from this multiplexer to the PC source, or if the destination is R15, then the address will be taken from the R15 register, right? And this PC also will be killed if the condition logic is generating a 0, right? So if the condition is false, again the PC source also will be made as 0, right? So the PC source, register write and memory write, all are connected to a condition logic. The condition logic is generating a 0, all these outputs will be 0. So basically the PC logic decides what value should be written to the PC, whether it should be based on writing to destination register 15, right, or whether it is based on a branch. So this is a function deciding the PC source signal. Then the last one we will see, that is a conditional logic. So this is a conditional logic we have seen, conditional logic. So till now we are dealing with this. You have seen ALE decoder, main decoder and PC logic. That was a decoder. Next we are going to see the conditional logic. This is a conditional logic. So conditional logic, it determines whether the instruction should be executed based on the condition field and the current values of NZCBQ, right? So the condition, this is a conditional logic. So conditional logic will determine whether the instruction should be executed based on the condition field. You have seen the condition field last 4 bits. Based on the condition field, whether the instruction has to be executed. So if the condition is true, this condition EX will be made as 1. So the instruction will be executed. And the instruction will be executed based on the condition field and the based on this flags, based on the flags. If the instruction should not be executed, the write enables and the PC will be made as 0. How it is done? If this condition logic is generating an output 0, both the write enables and the PC source will be made as 0. So if PC source is 0, the PC will not be, PC source is 0, PC will not be getting the actual value. Then the write will not be 0, so it won't be written to register or memory. That means the execution of the function will be stopped. So if an instruction should not be executed, the write enables and the PC source will be forced to 0. Right? Then the conditional logic also updates some or all the flags, right, based on the flag W bit that we have already seen, right? Based on the flag write bit or flag W bit, 2 bits are there, 0 and 1. Based on these two signals, right, and based on the ALU flag, the corresponding flags will be set. If you are performing AND or sub, all the flags will be reflected. That means both these bits will be set. Or if you are performing AND or OR, only the N and Z flags will be set. Right. So this flag setting is also controlled by the conditional logic. So the conditional logic will control the flag W bit, or it will control the flag W bits and these 3 bits such as PC source, register write and memory write. So all these 4 control signals, these 4 control signals are controlled by the conditional logic. So based on the condition, only the instruction can be executed. So it is one of the most important feature of advanced RISC machine ARM. This is one of the most important feature. All the instructions are having condition field. If the condition is not satisfied, that instruction will not be executed. But all the other microcontrollers are not having like that. There are separate conditional instructions are there. But here it is not like that way. Only if a condition is satisfied, then only the corresponding instruction will be executed. So all the instructions are having condition field.